Imagine standing on a cliff at the edge of the world, staring into the night sky, where countless stars glimmer like whispered secrets. For as long as humans have walked this earth, we've gazed upward, wondering if we're alone. It's a question that tugs at the heart, stays the mind, and fuels our wildest dreams. Are there others out there, looking back at us, asking the same? The universe, vast and enigmatic, has kept its answers hidden. But now, with the James Webb Space Telescope peering into the cosmos, we're closer than ever to unraveling the mystery of alien life. This isn't just about finding distant worlds or faint signals. It's about discovering who we are, where we fit, and whether the universe is as lonely as it sometimes feels. 4 light-years away, a rocky planet called Proxima b orbits a dim red star, Proxima Centauri, the closest stellar neighbor to our Sun. This world, just a whisper larger than Earth, dances in a tight orbit, spinning around its star every 11 days. Unlike our planet, basking in the sun's warmth over a leisurely year, Proxima b lives in a strange rhythm, possibly locked in a tidal embrace where one side forever faces its star's faint glow, while the other lingers in eternal shadow. Picture it, a planet split between scorching day and frozen night, a cosmic yin and yang. Could life thrive in such a place? Could a civilization, advanced beyond our imagination, harness the star's energy to light up the dark? The idea isn't as far-fetched as it sounds. Scientists have speculated that if Proxima b hosts a society clever enough to blanket its sunlit side with solar panels, the glow of their artificial lights might spill into space, a beacon we could detect with tools like the JWST. This telescope, a marvel of human ingenuity, is no ordinary stargazer. Launched in 2021, it's a time machine, capturing light that's traveled billions of years to reach us. Its golden mirrors, spanning 21 feet, drink in the universe's infrared whispers, revealing secrets from the birth of galaxies to the atmospheres of distant worlds. Proxima b is one of its prime targets, a planet that's tantalizingly close in cosmic terms, yet maddeningly out of reach. At 4.25 light-years, it's a distance no human craft could cross in a lifetime. But light is our messenger. And the JWST is our finest listener, tuned to catch the faintest hints of something extraordinary. What would it mean to find a signal, a flicker of engineered light from Proxima b? Not just a natural glow, but something deliberate, like the hum of a city seen from space. It's a possibility that sends shivers down the spine. In 2021, researchers like Manasvi Lingam proposed that a civilization on a tidally locked planet could transfer energy from the starlet's side to the dark, using sprawling solar farms. The excess light, reflected or emitted, could be bright enough for our telescopes to notice. Back then, it was a bold hypothesis, a thought experiment rooted in science but reaching for the stars. Now, with the JWST's unmatched precision, we're no longer just dreaming. We're searching, scanning the skies for clues that could rewrite our place in the universe. The quest for alien life isn't new. It's woven into our history, from ancient myths of gods in the heavens to modern tales of little green men. In 1978, astronomers first hinted at planets beyond our solar system, though their claims were met with skepticism. It wasn't until 1992 that the first exoplanet was confirmed, orbiting a pulsar, a dead star's remnant. By 2003, the discoveries were piling up, and today, as of April 2024, we've cataloged 5,653 exoplanets across 4,161 systems, 196 of them home to multiple worlds. Most of these orbit red dwarfs like Proxima Centauri, small stars that burn cool and long, outnumbering every other type in the Milky Way. These stars, faint and elusive, are hard to study, but their planets are gold mines for astronomers. Proxima b, discovered in 2016, is the crown jewel, not just because it's close, but because it sits in the Goldilocks zone, where liquid water, and maybe life, could exist. Proxima b is no Earth twin, though. Its star, an M-dwarf, is a temperamental host, emitting just a fraction of the sun's light, mostly in infrared. At 3,900 Kelvin, it's cooler than our Sun, and its energy output is a mere 0.16% of what Earth receives. Proxima b orbits at a scant 0.04856 astronomical units, closer than Mercury is to the Sun, yet its star's dimness keeps it in the habitable zone. That proximity comes with challenges. Red dwarfs are prone to flares, bursts of radiation that could strip a planet's atmosphere or sterilize its surface. If Proxima b is tidally locked, the star-facing side might be a scorched desert, the dark side a frozen wasteland. Yet, between these extremes, a twilight zone could exist, a narrow band where conditions might be just right. What makes Proxima b so compelling is its potential to answer questions we've asked for centuries. Could life emerge on a world so different from ours? Could intelligence flourish there? Building cities, machines, or even starships? The JWST is our best shot at finding out. Its mission is vast: to peer back to the universe's first stars, to watch galaxies form, to study how planets like Proxima b came to be. It's already detected signs of atmospheres on distant worlds, analyzing the light that passes through their gases to reveal their chemistry. Water vapor, methane, carbon dioxide. These are the fingerprints of habitability, and maybe, just maybe, of life. But what if we find more than chemistry? What if the JWST spots something unmistakable, like the glow of artificial lights or the heat signature of industrial activity? The idea stretches the imagination, yet it's grounded in science. A civilization advanced enough to survive on Proxima b would need to master its environment, perhaps by capturing every ray of its star's light. Solar panels stretching across continents could power a world, their reflected light a signal to anyone watching. The JWST's infrared sensitivity is perfect for this task, capable of detecting subtle changes in a planet's light curve that might betray a technological presence. This possibility raises profound questions. If we find such a signal, what does it mean for us? The discovery of intelligent life would be a turning point, akin to Copernicus declaring Earth wasn't the center of the universe or Armstrong stepping onto the moon. It would force us to rethink our history, our philosophies, our religions. Are we ready for that? For millennia, we've told stories of other worlds, from Plato's musings to Hollywood's blockbusters. Yet the reality could be stranger, more humbling. An alien civilization might not resemble us at all. They could be beings of light, of code, or something we can't even fathom. Or they might be gone. Their light's a lingering echo of a society long extinct. The search for life is more than a scientific endeavor. It's a mirror held up to humanity. Every step we take, every telescope we build, every equation we solve, reveals as much about ourselves as it does about the cosmos. We're driven by a need to know, to connect, to find meaning in a universe that often feels indifferent. Proxima b, with its mysteries, is a canvas for that longing. It's not just a planet. It's a symbol of what we hope to find and what we fear we might not. The JWST, hovering a million miles from Earth, is our brush, painting a picture of what's possible. Let's step back and consider the journey that brought us here. Humanity's obsession with the stars began long before telescopes. Ancient Sumerians etched constellations on clay tablets. Medieval scholars debated the plurality of worlds. By the 20th century, we were sending radio signals into space, hoping someone was listening. The SETI program, launched in the 1960s, scanned the skies for extraterrestrial transmissions, finding only silence. But silence doesn't mean absence. The universe is vast, with 200 billion stars in the Milky Way alone, each potentially hosting planets. If even a fraction of those have life, the odds of intelligent civilizations seem promising. The Fermi paradox, why haven't we found them, looms large, but tools like the JWST are shrinking the gap between question and answer. Proxima b's discovery in 2016 was a milestone. Found by the European Southern Observatory, it sparked a frenzy of research. Its proximity made it a prime target, not just for telescopes but for our imaginations. Scientists modeled its climate, its atmosphere, its potential for life. Some envisioned oceans lapping at rocky shores. Others saw a barren world, scorched by stellar flares. The truth likely lies in between, and the JWST is our key to finding it. By analyzing the planet's light, it can detect gases like oxygen or methane, signs of biological or even technological activity. If Proxima b has an atmosphere, it might shield life from its star's wrath. If it has technology, it might shine in ways we can see. The implications of such a discovery are staggering. Imagine the headlines. JWST finds signs of alien civilization. Social media would explode, philosophers would publish tomes, and governments would scramble to respond. Would we send a message, a probe, or nothing at all? The closest we've come to this moment was in 1977, when the Voyager probes carried golden records into space, etched with sounds and images of Earth. Those records were a gesture, a hope that someone, someday, might find them. A signal from Proxima b would be the universe's reply, a confirmation that we're not shouting into the void. Yet, the search isn't just about finding aliens. It's about understanding life itself. How does it begin? How does it endure? Proxima b, with its extreme conditions, is a laboratory for these questions. If life exists there, it might be utterly unlike Earth's, thriving in ways we can't predict. Microbes in subsurface oceans, plants that photosynthesize infrared light, or machines that outlive their creators, all are possible. The JWST's data could reveal these secrets, not just about Proxima b, but about the rules of life across the cosmos. This brings us to the heart of the matter. Why do we search? It's not just curiosity, though that's a powerful force. It's about purpose. Humans have always sought meaning beyond survival. We build pyramids, write symphonies, launch telescopes into the void. The JWST is an extension of that drive, a tool born from our need to know more, to be more. Finding life on Proxima b wouldn't just answer a question. It would redefine what it means to be human. It would remind us that we're part of something larger, a tapestry of existence stretching across light years. Of course, there are skeptics. Some argue we're chasing shadows, that the universe is too vast, too hostile, for life to be common. Red dwarfs like Proxima Centauri are tricky hosts. Their flares could render planets lifeless, and tidal locking might create climates too extreme for anything complex. Yet, life on Earth has surprised us before, thriving in deep-sea vents, Antarctic ice, and acidic springs. If life can endure such extremes here, why not on Proxima b? The JWST's ability to probe these worlds gives us hope, not certainty, but hope is enough to keep us looking. There's also the question of what we'd do with a discovery. If we detect artificial light, how do we interpret it? Is it a city, a factory, or something we can't even name? And what if we find nothing? No life, no signals, just a barren rock. That, too, would be profound. It would tell us life is rare, perhaps unique to Earth, making our planet a cosmic miracle. Either way, the act of searching shapes us. Every spectrum analyzed, every photon collected, adds to our story. The JWST isn't just a telescope. It's a testament to our refusal to stop asking questions. As we stand on this cosmic cliff, the universe feels both vast and intimate. Proxima b, a mere 4.25 light-years away, is a neighbor in galactic terms, yet it holds mysteries as deep as those of the farthest quasars. The JWST, with its golden mirrors and infrared eyes, is our guide, revealing glimpses of what might be. Whether we find life or not, the journey matters. Each discovery, from the first exoplanet to the latest JWST image, builds our understanding of the cosmos and ourselves. We're not just looking for aliens. We're looking for meaning, for connection, for a sense of home in a universe that's both beautiful and bewildering. The stars have always called to us, and now, with tools like the JWST, we can answer. Proxima b might be the first step, a world close enough to touch with light, if not with hands. Its secrets, locked in its rocky surface or hidden in its skies, are within our grasp. The search for life is a search for truth, for purpose, for the courage to keep asking, what's out there? As we peer through the JWST's lens, we're not just explorers, we're dreamers, weaving a story that began with the first stargazers and will continue as long as there are stars to see. Let's keep looking, not because we expect answers, but because the act of looking defines us. The universe is vast, but so is our curiosity. And in that vastness, in the light of a distant world, we might just find ourselves.